Hey guys, Mrs. Marquette here. You are done with 2 weeks of virtual learning going into week 3. And I just want to stop and take a moment to recognize that that's a big deal. I've literally never had a group of high school students make it through 2 full weeks of online learning before. So I know it might be a little bit rough at times. I know it might be hard to stay focused, but I'm really proud of you. So keep up the good work. And as always, please reach out if you need anything. I'm here, not just for math, but if you need to vent a little bit, let me know. I'm here for you. So today we are going to continue with right triangle trig. So all of our triangles today have right angles, but we're specifically going to be working on some word problems. Exciting! And when you're talking about right triangle trig and word problems, specifically like SOH trig, so we're still working SOH. Um, most of your word problems are going to be of two basic types. They're going to be problems that have angles of elevation or angles of depression. Okay, so we're going to be talking about an angle of elevation here, an angle of depression here. Okay, so you'll hear those words a lot. You have to be able to tell what an angle of depression is versus an angle of elevation. So what you're going to think is that your angles of elevation depression always, always, always start from a horizontal line. Okay, an angle of elevation, your horizontal line is going to be the floor. Okay, so you're on the or your starting point is the floor, and then your angle elevates up from the floor. So here's the floor, and then I'm here. If you can see my iPad, my angle elevates up. Okay, so then my angle goes from the floor to up. Depression is harder. So the elevation is the easier one. Depression is harder because we can actually think about seeing a floor and then elevating up, whereas depression is a ceiling angle. So it starts at the ceiling and then actually depresses down. And this is the angle right there. So your ceiling, you have your other side or your hypotenuse, it's going to depress down. So you're going from the ceiling down. The tricky thing about your angle of depression is oftentimes you have to draw the ceiling. You can't just see the ceiling. Like I'm in my apartment right now. I can see the floor, and technically I can see the ceiling too, and I can think about something coming down from the ceiling. But if I'm outside, it's harder to see an actual ceiling. So you have to kind of draw that. Okay, so that's the first part. Whenever you do a word problem, you have to draw a picture. So always, always, always draw a picture first. So draw or sketch it out every time. And then the key is knowing, are you looking for angle of elevation, angle of depression? So it says, number one, a ladder 32 feet long leans against the side of the building, makes an angle of 75 degrees with the ground. Okay, so here are my pieces of information. So I've got a building. Okay, so there's my building wall. And then I've got this ladder. So that's my setup. The ladder is 32 feet long. So you got to think about what side of my triangle is this really. So I can even draw the floor here. So my ladder is the thing that's 32 feet. Okay, and then it makes an angle of 75 degrees with the ground. Okay, so that's actually going to be an angle of elevation. So starting from the ground, going up, this is 75 degrees. Okay, they want to know how high above the ground is the top of the ladder. The top here is right up there. So really, I want to know how high is it from here to here. We could call that H for height. We could call it X if we wanted, but now we have a really good picture. We can assume that our angle is a right angle because your building with the ground are usually made with right angles. So if I have this all labeled, then I'm just thinking SOH. What do I have going on here? So I have an angle, I have the opposite side, and I have the hypotenuse. Okay, so it seems to me like I have sine, opposite, hypotenuse going on. So my sine of my angle, 75, is equal to the opposite side, h, over the hypotenuse, 32. Multiply by 32 on both sides, and 32 times the sine of 75 is equal to the height. So I get that 30.9096 is equal to the height. They specifically say the nearest tenth of the degree and lengths to the nearest whole number. So my length, I want to go to the nearest whole number. So it is 31 feet high. And again, I round to the nearest whole number because that's exactly what they told me to do, how high above the ground. So this is actually a length in feet because the ladder was measured in feet. So that's why I say 31 feet high. Okay. Great. Number 2, the angle of depression from a shipwreck on the ocean floor is 10.9 degrees. If the depth of the ocean at the wreck is 156 meters, how far should the ship sail so it's directly above the wreck? That's kind of an interesting problem. So I've got this ocean. I have my boat, and it's looking at a wreck on the ground or on the ocean floor. So here's my ocean floor. I have a wreck down here like that. And then they say the angle of depression. So you want to know, what is that angle of depression? Okay, so the ship is looking from this ship to this ship. The problem is that my angle of depression could be this one right here, or it could be this one right here. Okay, so this is kind of the biggest, trickiest part of the whole day. So you want to think, what is the ceiling here specifically, because this is an angle of depression. Okay, so the ceiling is actually going to be like the top of the ocean. All right, so think ceiling being like the top. Okay, so I want to depress down from the ceiling. So I can actually draw this triangle right here. Okay, I can have a right angle. This is my ceiling, which means that this is the angle of depression. Okay, so the angle of depression is 10.9 degrees. And the depth of the ocean at the wreck is 156 meters. So I want to know, is that 156 meters here or 156 meters here? Well, it's talking about the depth of the ocean. When we measure the depth of the ocean, we always measure like the surface to the actual bottom of the ocean, so the actual ocean floor. So it's going to be the vertical distance. And then they want to know, how far should the ship sail so that it's above the wreck? Well, the ship can't sail at a diagonal into the water. It's not a submarine. So we're actually looking for this side of our triangle. Okay, so now we have a nice picture. Looking at what everything's going on here, this is my reference angle. So I have the opposite side. I have the adjacent side. So it looks like I have TOA. Right, I've got tangent, opposite, adjacent. So tangent of my angle is equal to the opposite side, 156 over x. Remember, this is the harder type of problem to solve, but I can still multiply by x, multiply by x. I have x times the tangent of 10.9 is equal to 156. Remember that tangent of 10.9 is just a number. I could plug that into my calculator. So I divide both sides by tan 10.9. And I get x is equal to 156 divided by tan 10.9. And I get 810.0965. So if I'm rounding again to the nearest meter, then I get x is equal to 810 meters. Notice this time I'm in meters, not feet, because my other length is measured in meters. Okay, so the ship should sail 810 meters. Moving on. Number 3, the angle of elevation to the top of the lighthouse from a ship 90 feet away on a straight line with the base of the lighthouse is 26 degrees. Find the height of the lighthouse. So notice they drew this picture up for us. The angle of elevation, though, remember, is always from the floor. So does that jive with what's going on here? This is our floor. And then I elevate up. So yeah, that is the angle of elevation. They want to know what is the height of the lighthouse. So I'm going to label that there. Okay. So now I have an angle. I have an opposite. This is my adjacent. So I will say that I've got a TOA again. So this is the tangent of 26 is h, so the opposite over 90. Notice again, I'm in feet now, not meters, so back like number 1. So I can multiply by 90 on both sides. So I do 90 times tangent of 26, and I get 43.896 is equal to the height. Okay. Going back again to our directions, how high are we to the nearest whole number? I have 44 feet high. Or I guess I could say 44 feet tall. That is the height of that lighthouse. Okay, so you're going to get into kind of a pattern with this, but again, it's all about knowing what angle you're looking at and how do I make the picture. So don't forget to draw it. All right, support wire runs from the top of a utility pole that is 50 feet tall to a point on the ground that is 33 feet from the base of the pole. What angle does the wire make with the ground? Okay, so I have a utility pole, and I've got a wire that runs to the ground. I know that the utility pole is 50 feet tall. Okay, the point on the ground is 33 feet from the base of the pole. So this is the pole. We're 33 feet away. And I want to know what angle does the wire make with the ground. So wire make with the ground, is that angle of elevation or angle of depression? Well, you're looking for the ground, so the ground is going to be angle of elevation. So I don't know what it is. I'm going to label it X, or in our case, we're going to call it theta. All right. Again, think about what you have. So I have opposite from my reference angle. I have the adjacent. So I have TOA. We've dealt a lot with tangent for these word problems. So tangent of that angle is equal to the opposite, which is 50, over 33. Notice this time I'm trying to look for the angle. When you try to look for the angle, you're doing your inverse trig operations. So I want to undo tangent. So I take tan inverse on both sides, and I get that theta is equal to tan inverse 50 over 33. In your calculator, second tan, 50 divided by 33, I get that theta is 56.575. Okay, going back to our directions at the beginning, they say round your angles to the nearest tenth of a degree. So the angle, theta, my final answer will be 56.6 degrees. Don't forget that degree symbol. Okay, So that's just a couple examples of word problems. What you guys are going to do today for your homework is actually an activity that we like to do at school. We like to have you guys go around the school and kind of see different angles and lengths and actually measure things yourselves. What you're going to do instead is you are going to do a class kick. So in the email, I gave you a class kick code. The pictures that are in that class kick are actually from campus. You're going to solve about 4 problems, and that's your whole homework for today. Okay? Make sure that you're showing all of your work, and you can actually type in your answers into that green box, and then it should tell you if you have the answers correct or incorrect. But if you don't show work, then you're not going to get points for it. Okay. The other thing that I'm going to let you do for this is if you and a partner want to get together like on FaceTime or Duo and work through this together and be working on Class Kick, as long as you put both of your names on that first page, I will give you guys credit for working in groups. So I'm going to say groups of up to 3 people maximum, but if you choose to work by yourself, that's okay too. All right. I will be on my iPad today from 9 until 11. So if you guys want to do the class kick at that time, then I can give you immediate feedback if you have questions. But otherwise, you can do this anytime. This will be due next red day, so that'll be Wednesday at 8:25 a.m. Okay, so let me know if you have questions. Good luck.